Hello. Yes, this is another example for using GEE to fit so-called three-level data. As we know, in general, longitudinal data analysis involves repeated measures over time. So it's a repeated measures within the same person. That's we call two-level data. So GEE and also linear mixed models are initially designed for handling two-level data. But in multi-level modeling, there's really no limitations on the number of levels. For example, we can have 3 level, 4 levels, or even higher level of data from different type of research, such as using the social ecological model to do multi-level interventions. Okay, so you get the intervention from the state, from the city, from the neighborhood, to family, and to individuals. You can have 4, 5, 6 levels of clustering. So here is an example that we try to use GEE to model 3-level data, and an acknowledgement that this example is from a book by Stokes, Davis, and Couch, published in 1995, called Categorical Data Analysis Using the SAS System. And the SAS code is from the SAS institution. Okay. So here we're reading the data. So its name is RESP. I think this study has something to do with respiratory health. So we keep the ID active, center 2, female, age, baseline, visit, and outcome. And then we input center, ID, treatment, and sex, age, baseline, and visit 1 to 4. So here's some labeling. Active equal to this, so that's a dichotomization. And center 2 equal to center equal to 2. Female equal to sex equal to F. Okay. And here's the visit equal to 1, outcome equal to visit 1, visit equal to 2, outcome equal to visit 2 output. So this is another way to create the long format of the data set after reading in the wide format of the data set. Okay. And then we use a card statement and to read in all the data set, the data values. Okay. So so the data is pretty long, but we put them in the card statement and gonna read in. So let's run this. Okay. So it tells us the data set has 444 observations and 9 variables. Okay. And here's the SAS code to fit the so-called 3-level data. Okay. So proc_gen_mod data equal to RESP. The class statement defines the categorical variables. And model statement outcome equal to center 2, the dichotomous center variable. Active, female, age, and baseline. Distribution equal to bin. And here's the really what this is. This SAS program is special. Okay, so subject, repeated subject equal to ID parenthesis center / type equal to n. Okay, so what this does is really put an ID, so that's the individual ID, and nested, so the ID, the individual, will be nested within the center. Okay, and since we're using the repeated statement, so for each individual he has repeated measures nested within the same individual, and then the individuals are nested within the same center. So there's 3-level data, but 2 levels of clustering. Okay, and these can be implemented in SAS by using this ID parenthesis center. Okay, so you can have the highest level of clustering occurs at the center, and then down one level down you get the ID, the individual, and the third level is within the individual you get the repeat measures. So the 3-level data, 2 levels of clustering. Okay. However, we know the clustering causes correlation, but the correlation now can be very complex because it can come from the clustering at the center level, because maybe all the patients from the same center have some kind of similarities. Okay, so their outcome are dependent. And then, of course, repeated measure within the same individual are correlated. So you have another clustering, so you also have correlation there. So when you look at the repeated measures, they are correlated, but the correlation can come from the same individual level, and also at the same center. But we really don't know what exactly that correlation structure is. We have no experience, we have no knowledge. So what we do is say we're just assume the most general and structure correlation structure. So that is also important because we really don't know anything about the correlation. So here we have actually multi-level correlation structure. Okay, so the best thing we can do here is really to trick SAS to do a 3-level model by actually using a 2-level model. Okay, so to fit a 3-level data by using a 2-level model and assuming we know nothing about the correlation structure. Okay, so this is really our model equation actually really don't have a explicit way to address the multi-level correlation structure. So but we're just tricking SAS to do it. Okay, so let's take a look. Okay, so SAS did fit the model, and it comes out just like the usual GEE modeling. Okay, but now we have ID and we have center here. Okay, ID and the center. So we have 2 centers and we have 56 IDs. So in total, how many subjects do we have? We have 112, right? And everything else is the same. Since we did not specify model SE, SAS only print out the empirical standard error estimates based on the sandwich estimate. Okay, so and we did not specify type 3 since we don't have multi-category categorical predictor here. Okay, and SAS since version 9.2, the ProcGenMo GEE does provide the QIC and the QICU. So everything turns out it works out well, but here, okay, subject effect, we get ID nested within center, so we get actually 111 clusters. Okay, so yeah, I think, yeah, so here we we don't know exactly. We have to do some cross tabulation to figure out how many are in center 1, how many in center 2. But what SAS did is really this becomes the variable that SAS loops through to get all the repeat measures. So it's gonna look for a center, and then within the same center to go to the first ID and loop through all the repeat measures, and then go to the next ID and loop through all the repeat measures, and after that go to the next center, do the same thing. Okay, so this is, if you think this as just one variable for the subject equal to the variable, then it's sort of, we're still doing a two-level model, but we kind of combine ID and center to trick us to think it is a one variable. Okay. So did we fit a three-level model? Kind of.